Let's take a look at this problem. We're going to solve it with loop analysis, but this time we're going to have a 4.8 amp current source in it. I did a video on the basics of loop analysis. Give it a watch there if you haven't. But for now, let's try this one. So here's our 4 meshes. And let's go ahead and draw our 4 current directions. So we'll do I1, I2, I3, and I4. Right, first off, our goal is going to be to find the voltage across this 10 ohm resistor. And secondly, yeah, I hand drew this and it's a little crooked, so my apologies. So first, let's evaluate I1. So I1 is the current in these wires. This wire is going to share I1 coming down and I2 going up. But we already know, because we have this 4.8 amp source, I1 equals 4.8 amps. All right, we're partway there. Now, let's evaluate I2. So we're going to start with 0 equals, and we're going to go around the loop the direction we're pointing. So first, we come to the 7.5 ohm resistor. And also, just to make things easier, let's go ahead and mark our resistors. So do plus on top, minus on bottom. And again, it doesn't matter which way you do it, just be consistent throughout. They already gave us that the voltage here is positive on top, negative on the bottom. So over here, we'll do positive on top, negative on bottom for this 2.5 ohm. And we'll do plus minus here. We also have a dependent voltage here that has given polarity and a voltage source over here with given polarity. All right, but let's focus back on our second mesh here. So this arrow comes and hits the negative sign first. So we're going to have negative 7.5 ohm. Then we have I1 coming down, starting at the plus, I2 going up, so it'll be I1 minus I2 for the current. Next, forgot to mark those. We come to this one. So we hit the plus first. So that's just going to be I2 times 2.5 ohms. Then we come back down. We're hitting that plus first. That's going to be on a 10 ohm resistor that's shared with I3. So we'll write plus 10 ohms times I2 minus I3. Now we're just going to do some algebra and simplify. So we're going to have to distribute, and let's see what we get here. So now we end up with 0 equals negative 7.5 ohm I1 plus 7.5 ohm I2 plus 2.5 ohm I2 plus 10 ohm I2 minus 10 ohm I3. But we already know I1 equals 4.8 amps. We have I1 right here. So we can take our negative 7.5 ohms, multiply it by our 4.8 amps, and they'll give us negative 36 volts. While we're doing this, let's go ahead and combine some like terms. So we have 7.5 ohm I2 plus 2.5 ohm I2 plus 10 ohm I2. All right, now we can simplify some more. Let's move 36 volts over, combine the 10 ohm I2s, and that's as simplified as that one's going to get. So we'll star it. We're going to save that for later. Now let's move on to I3. So let's start at the top here. So we're going to go this way. Negative 1 ohm IX. I just realized I never defined where IX is. Just so we know, this is IX. It's the current coming down this way, so it's going to be whatever I1 minus I2 is. So now we'll continue this way. We hit that positive 2.5 ohm resistor that's shared with I4, so we have plus. So it'll give us plus 2.5 ohms times I3 minus I4. We're going to continue around. That negative side of the 10 ohm resistor. And again, this is going to be I2 minus I3. Let's make a note off to the side here. So what is IX? Why, it's I1 minus I2. But remember, I1 is 4.8 amps. So we can just say IX equals 4.8 amps minus I2. So we can fill that in here. So now let's fill that in and do our distributions. First we have negative 1 ohm times 4.8 amps, which of course is going to be negative 4.8 volts. Then we're going to keep distributing. So now that we made 4.8 volts, let's go ahead and add that over and start combining like terms. I know I'm doing a lot of excessive steps, but this is just so you can follow along one little step at a time. So we should have 4.8 volts equals negative 9 ohms I2 plus 12.5 ohms I3 minus 2.5 ohms I4. And that's not going to simplify any further, so it gets a star. Then we got one mesh to go. Now let's solve for loop I4. So first, let's go this way. Let's set the positive end of that 1 ohm resistor. So 0 will equal 1 ohm I4. Then we'll go this way, plus 12 volts. Then around this way, that negative sign of the 2.5 ohm resistor. Remember, we had I3 minus I4, so we'll do negative 2.5 ohms times I3 minus I4. We're going to move the 12 volts over and distribute. Now we just simplify the two I4s. So now we have negative 12 volts equals negative I3 2.5 ohm, and no, it does not matter which order you write those in because they're being multiplied, plus 3.5 ohm I4. And that's our final equation. Now remember, our goal is to find this voltage. We know that I1 is 4.8 amps, but we don't know I2, I3, or I4. We have three unknowns, and we have three equations with those unknowns. So let's write all those equations that we started so far in a nice, neat little area and do some linear algebra. Now that we have our three equations, let's set these things up for some linear algebra. So remember, V equals IR. But currents, I2, I3, I4 are the unknowns. So we have resistance. So we need V over R equals I. But for matrices, we're going to do this. We're just going to do the inverse of our resistors. In other words, it's going to be conductance. So V times R to the negative 1 is going to equal I. And here I have 0 I2 for equation 3 because there is no I2. And up here we have 0 I4 in equation 1 because there is no I4. So this just keeps the I2s lined up, the I3s lined up, and the I4s lined up. And here we have the voltages together. So just keep it nice and organized, and you'll knock it out. So let's use this equation to find our values for I. First, let's do the three voltages. So there's our first matrix, that's V. We're going to multiply it by R. And we're just going to go down the row. So we're going to be 20, negative 10, 0. Then negative 9, 12.5, negative 2.5. Lastly, 0, negative 2.5, 3.5. Don't forget, that's going to be inversed. So we're going to raise it to the power of negative 1. And that's going to equal I2, I3, I4. Okay, so I went ahead and put in all my information from my matrices. So we got our 3 by 3, which we need to invert. There we go. Multiply it by our 3 by 1. There's your currents. So this equals I2 is 2.8, I3 is 2, I4 negative 2 amps. So now the bulk of that is done, but we still want to find V. So we can see the current going through V is going to be I2 minus I3. So let's do that. So I2 minus I3 is going to equal, let me move this up a little bit, it will equal 2.8 amps minus 2 amps. There's my A for amps. So we have 0.8 amps. So we have 0.8 amps going through a 10 ohm resistor. So let's just box off some space. So V is going to equal 10 ohms times 0.8 amps, which equals 8 volts.